Let's look at the solution to these questions. So first one, what units will the Hubble parameter be measured in? We start off with our equation, which is just the recessional velocity divided by the distance it is away from us. So velocity will be meters per second, that will be meters. So our unit is seconds to the minus 1, so we can put it in down here. There's a little bit of debate as to exactly what h0 is. It's so hard to take measurements of it. So you will either be told it or else you can take it from your data sheet, which I think it is given as 2.4 by 10 to the minus 18. Next question then asks us the distance of a galaxy with recessional velocity of 0.5 c. So the velocity is 0.05, the speed of light. We're trying to find d, and our Hubble constant, our parameter, is 2.4 by 10 to the minus 18 per second. We just write out the equation. So v equals h0 d, sub in our values, so 0.05, we need to multiply that by the speed of light to get it into meters per second, equals 2.4 by 10 to the minus 18 times d. Dividing through gives you that the distance is 6.25 by 10 to the 24 meters. You are going to get quite high values for these when they're written in meters because the distances are so large. Next one says, what is the recessional velocity? So we're trying to find v of a galaxy that is a distance of 6.7 by 10 to the 23 meters away, and we'll use the same Hubble constant of 2.4 by 10 to the minus 18 seconds to the minus 1. Once again, just write out the equation. Put in your values, so v equals 2.4 by 10 to the minus 18 multiplied by 6.7 by 10 to the 23, which should give you a velocity of 1.61 by 10 to the 6 meters per second. Okay, part C is a lot harder because we have a number of steps to get to the answer here. But it says calculate the distance, so we're trying to find d, of a galaxy whose 420 nanometer absorption line is observed to be at 500 nanometers, which means delta lambda there is 80 nanometers, and we're trying to find d. Now we're going to do that by using v equals h0 d, but to use that equation we know h0, we don't know what v is, so we have to find v before we can do that. So our first step, so step 1, is to find the z parameter, which is just the difference in the wavelength divided by the wavelength, which is 80 over 420. Those are nanometers. We could put in the by 10 to the minus 9 and the by 10 to the minus 9, but they just cancel out, so you actually just ignore it in this case. That gives us a z parameter of 0.1905. We can then use that in our second step, our second equation. The second way we have of defining that z parameter is the ratio of velocity. So if I put in my values there, multiply by 3 to the 10 to the 8, gives me that the recessional velocity is 5.715 by 10 to the 7. You can see I'm keeping these answers to 4 significant figures so I can give my final answer to 3. Finally then, step 3, we can use Hubble's equation and put in our values. So 5.715 by 10 to the 7 equals our Hubble parameter, constant of 2.4 by 10 to the minus 18 times d, dividing through gives us d is 2.38 by 10 to the 25 meters. Like I say, there's a number of steps to that one. It'd be worth a lot of marks. Not one of the steps is hard, but it's knowing the steps to do to get there is the difficult thing in that question.